So once we have saved this class, we will move toward creating neural network class. So let's give it a new section heading, which is neural network class. Escape and press M. Then class neural network. Let's define the constructor or the initializer here, which is self, and then self dot fc1, and then dense 432. So why we are taking 4 here is because there are 4 features in our data set, and then we are expanding them into 32 hidden features. And then after this, we will be using the ReLU function. We are calling the ReLU here. So this is the layer 1 of our neural network. And then after fully connected, layer 2 here. Now here what we are doing is we are taking this 32 features, this output becomes input for this, and then compressing it into 16 hidden features. After this we will be implementing the ReLU again, which will be like self.ReLU2. After this, self dot fully connected 3, and then we will compress those 16 features into 3, and finally we will calculate the loss Fn using the softmax cross entropy. So yeah, this is the 3-layer initializer for our neural network. Now in our neural network, we will also try to have a forward passing network or the forward passing function. So let's write it: forward self x, and then our x will be equal to self dot fully connected 1 dot forward. We are using forward function here, which we have written above. Then x is equals to self dot fc2 dot, oh sorry, we have to write ReLU1 dot forward here, x. So as you can see, this is the capital X, which is given as the function parameter, and this is the small x, which is used here. And similarly below, we are just going to use x, and the output of the previous variable or the previous implementation will be input for the next one. Here dot ReLU2 dot forward x, and then x is equals to self dot fc3 dot forward x, and then we will return x. So this is the forward pass implementation. After this, we have to implement the training step. So the training step is the complete loop of learning. This is the most critical function for training. It performs one full iteration of learning, that is forward pass, backward pass, and wait update for a batch of data. So let's implement it. So let's write train step, which will take x, y, lr, and then take logits equals to self dot forward of x, then loss will be equal to self dot loss function dot forward logits, and then y. After that we will calculate the dz self.loss function dot backward pass. Again dz will be equal to self dot fc3 dot backward. So as you can see, we are just going backward by taking input from the previous layer, the output from the previous layer as the input for the current one. And then dz equals to self dot ReLU2 dot backward. Then again dz, and then dz equals to self dot fc2 dot backward dz. And let's continue it so that we complete our 3-layer implementation. So as you can see, we are going in reverse order. For forward pass, we started from fc1 to all the way down to fc3, and for the backward function we have started from the loss function and then we are going all the way to fc1. So again, let's write it again. Self dot fc1 backward dz, and then finally self dot, then we will update the weights for all the layers. fc2 update lr self dot fc3 dot update lr, and then finally we will return the loss for the training step, then return loss. So in this way we have implemented our train step function. After this we have to implement the predict function. So this predict function will be, in simple words, this function will be used after the network is trained to classify new unseen data into concrete class categories. That means this is the functions that we are really going to need. Like this will be the function that will give us the predictions for the values. So let's implement it. If predict equal to self x, and then logits equals to self dot forward x, and then exp equals to np dot logits. This is the same as we have implemented before, and keep dimensions equals to true. After this we will calculate the probs, that is the probabilities, softmax probabilities, which is like this: x is equals to 1, keep dims equals to true, and then we'll return np dot argmax probs x is equals to 1. Now we will just run this. So in here we are getting raw scores in logits using just running the forward pass, and after that we are calculating the clean probabilities using this expression, and finally we are making the final decisions using this expression. So this expression looks at the final probabilities and picks the index of the highest value. For instance, if the probabilities are like 0.1, 0.85 and 0.05, then the argmax function will take the index 1. So this will give us the probabilities, and this will select the index of the best possible class, like the class with the highest probability will be selected here.